Okay, so let's talk about this worksheet first, and then we'll get you started on your review, and your test will be tomorrow. So, number 1 was about the rock being dropped into the lake. I have a final answer of 48 pi inches squared per second. 48 pi is equivalent to 150.8 inches squared per second. So how's that one for everybody? Any issues? No? Okay, number 2. I have 2 over pi feet per second. The decimal approximation would be 0.64 feet per second. How did we do there? Just fine? Okay. Number 3, I have that dx dt is 7 1/5 feet per second, or 7.2 feet per second. I'm liking all the head nods. We're doing good here, huh? All right. Number 4, I have that dr dt is 3 over 16 pi, which is equivalent to 0.06 inches per second. How we doing? Still good? And number 5, I have that dd dt is 50 miles per hour. I don't have to do any of those? No? What? Good. I'm glad. Like I said, we should be narrowing in on the types of problems that we're going to be tested over anyways, okay? Obviously, some of those are harder than others. While you guys are doing your review today, I'm going to look at the extra credit that you gave me, and I'll let you know if you got all or any points from those questions, all right? Let's talk about your quiz. I can reach over here. Your quiz tomorrow will have 8 questions. Okay, 8 questions. How many questions does your review have? That's by design. Okay, by design. Let me read for you the first 4 words of one of your questions. Are you ready? At a given instant, the legs of a right triangle. So peruse your review for me. At a given instant, the legs of a right triangle. Okay, so this is by design. Okay, there is not meant to be any trickery here. You either know how to set up these problems or you don't. Okay, is that clear to everybody? 8 questions on your review, 8 questions on your test. Fair enough? Okay, I told you that I am going to let you know what you should round to on your test. If it doesn't tell you to round, then you don't round. Okay, then you give me the rationalized answer or you leave the pi in it. Does that make sense to everybody? Okay. Other than that, I don't have anything for you unless you have any questions for me. We're all okay? Yes. Yes. Are you ready to answer these specific ones? Okay, so you guys can go ahead and work. I'll answer Amanda's questions, and if you guys have any other questions for me, please ask. Amanda, I'm going to pull this up, and then we'll get going here. Okay, what number are we looking at, ma'am? Number 4. Okay. The hot air balloon? What's your static equation? V equals? Yeah. Okay, so let me come back around here and get all tangled up here. All right, so you're telling me your static equation is V equals 4/3 pi r cubed. Okay, can you tell me what you know? Oh. Okay, so we're going to have to look at this. Go ahead, tell me what you know. Okay, the spherical hot air balloon is being inflated at the rate of 325 feet cubed. Because of this cubed, that tells me it has to be volume. Okay, so I have 325 is dv dt. And it's increasing, so it's positive. Okay, what else do we know? And that's a specific instance in time, right? As is a 325. And I think that's probably all they give you. But what are you being asked to find? Okay, so I think I'm going to use SA for surface area, if that's okay, is what I'm trying to find. Now, here's my issue with this, Amanda. Your static equation is for volume. And I have dV dt, so I need that. But I'm being asked about the surface area, so we're also going to need a surface area formula. Do you have the surface area formula for a sphere? Perfect. Surface area is 4 pi r squared. Okay, so when you derive this, you're going to get dSA over dt, correct? You're also going to get an r, and you're going to get a dr dt. Now, I have an r, don't I? So I am going to need to find a dr dt. Okay, that's what I need to do here. And I think that's probably what we need this for. Okay, do I have a dv dt to put in here? Yes. Do I have an r to put in here? And when I derive this question, I'm also going to get a dr dt. So if I can solve for that dr dt, then I can do it here. Does that make sense? Okay, so let's derive that volume formula. I have dv dt equals 4 pi r squared dr dt. How's that? Now let's plug everything in that we know. dv dt is 325. 4 pi stays. The r is 15, going to be squared, and then I can find dr dt. Why don't you go ahead and do that for me? Leave it as an exact answer for me, Amanda. Correct. Now 325 over 900 should reduce, so. Pi, right? And the pi is on the bottom. Okay, so this is what I'm going to use for dr dt. Is that okay? All right, so now let's derive your surface area formula. So this would be dSA over dt. And if you just wanted to use A, obviously you could there. This would be 8 pi r dr dt. How is that? Good. So now let's plug in everything we know. We know dSA is what we're trying to find. 8 pi, my r is still that same 15. And my dr dt is at 13 over 36 pi. Now this is actually very appealing to me because you see the pi by the 8, right? And you see the pi on the bottom. What's going to happen to those? They're going to cancel. So basically all you have left to do is multiply 8, 15, and 13 over 36. Does that make sense? Okay, so go ahead and do that for me and tell me what you get here. It's a fraction, so don't be scared off by that. Or a repeating decimal, however you want to write it. That's an acceptable answer. Or you could tell me that would be 43 and 1/3, which would be the same thing. Or yep, that's okay. Or it could be 43.3 repeating. Any of those would be acceptable. But I do need a units on this. We're talking surface area, so it's got to be a squared unit. Correct. That would be feet squared per minute. Is that one okay? Okay. What else would you like to look at, ma'am? Correct. Correct. Yep. So she's asking me here, Dylan, because that bottom part, the one traveling east, I know that car is traveling at 40 miles an hour for 2 hours. So that would be 80 miles traveled. Okay. Anything else on number 3 there, Amanda? No, that one's okay. Do you have any other questions for me? Not right now? Were you able to do the whole thing? Awesome. How are the rest of you doing? Have you come across anything yet?